Hello, Mr. Collier here, and today we're going to do episode 3 of kinematics, and we're going to be talking about graphing. We're going to continue our discussion about speed and velocity, scalar and vector quantities. We're going to look at them from a graphing point of view. So a graph is a diagram that represents a system of connections or relationships among two quantities. And that's really what we're going to be looking at today is how does a graph show us the relationships between things? And the way that graphs will allow us to do this is to look both visually and mathematically at relationships. The most common mathematical relationship that we're going to be looking at this year is slope. And if you recall back to your math experiences, slope is the ratio of rise to run, or another way to think about that is the change in the y value divided by the change in the x values. The units for slope will tell us about the relationship. Now, a lot of times in math class, you just look at slope as a number without any units, but we're going to be graphing numbers with units, and so the slope actually will have units. For example, if your y value is distance and your x value is time, then you're going to have units for distance divided by units for time. And hey, guess what? Distance divided by time, that's the definition of speed or velocity, depending on whether you have a direction or not. Distances are usually measured in meters, time in seconds, so perhaps your units are meters per second. So let's look at an example here of a graph showing us the position where something is compared to the time, how long it's been moving. So for this first segment from A to B, the slope is equal to the change in y, so it goes from 0 to 20, 20 minus 0 on the y, that's a change of 20. The x-axis goes from 0 to 4, 4 minus 0, that's a change of 4. 20 divided by 4, that's 5. We're looking at meters and seconds, so the slope of this line tells us that the object, the person walking, is traveling 5 meters every second. For segment BC here, we have no change in the y value. In other words, it starts at 20 meters and it ends at 20 meters, so it hasn't changed its position. And so therefore, the only way to explain that is to say that it's not moving. And this is represented by a slope of 0. 0 slope, 0 motion, 0 speed. Segment CD here has the same slope as slope AB, only now we're looking at a change from 20 meters to 40 meters. And a change in 4 seconds. Two slopes that are the same tell us that we have two segments where we're traveling at the same speed. Here for segment DE, we have something we haven't seen before, which is a negative slope. And when you calculate a negative slope, of course, you get a negative number. And if you think about what that means in terms of speed, it's telling us that the direction has changed, right? So now we're actually able to talk about velocity, not just speed. So we can look at negative slopes as moving back toward the direction of the origin. In this case, we're talking about someone walking to the IMC or to C-pod. In this case, it's back toward C-pod, whereas these original positive speeds would be heading toward the IMC. So the positive or negative aspect of the slope tells you the direction of the motion, allows us to talk about velocity. And finally, in this last segment, we have something we haven't seen, which is a curved line. When you have curved lines, that means your slope is changing, and a changing slope means a changing speed. Since the speed is changing, the only way to know an instantaneous speed is to draw a line tangent to the curve, in other words, touching it at only one point at the spot where you want to know the speed, and then figuring out the slope of that tangent line. We're not going to do too much of that, but I do want you to understand that the curving line tells you that the speed is changing because the slope is changing. So now let's look at a different type of graph. Now instead of looking at position versus time, we're looking at velocity versus time. So what's the slope going to tell us in a velocity versus time graph? So what we're seeing here is that the velocity, as time changes, the velocity is changing. So in this case, the velocity is increasing. And an increasing velocity you would know as something speeding up. And if we find the slope of this, we get a change in speed over an amount of time. And so our units here, change in speed per time, this is a new term. This is actually something we call acceleration, speeding up or slowing down. Acceleration is defined as the rate of change of velocity, or how velocity changes over time. Now, something to consider about this is that velocity is a vector, And so you can change velocity by speeding up, by slowing down, but since it's a vector, you can also change it by changing direction. So that means acceleration can happen when an object speeds up, slows down, or changes direction, even if the speed remains the same. All right, we've got two different equations here that we can use to talk about acceleration. Both of them have an A for acceleration. Both of them are really just relating a change in velocity over time. And we can look at that as final minus initial in terms of changing velocity, or 2 minus 1 is another way to think of it as well. So now let's analyze this graph by looking at acceleration. When acceleration is happening, you'll have a slope. But when the slope is 0, you find that there's no change in velocity. In other words, the velocity is constant. So when you have a flat line, 0 slope tells you there is no acceleration. Now, no acceleration doesn't mean it's not moving, it just means it's not speeding up or slowing down or changing direction. Here we have a slope that is the same as that first slope I showed you, an acceleration of 5 meters per second squared. And what does that mean? It means that the velocity is increasing at a rate of 5 meters per second every second that it passes. And finally, we can also have a negative slope on velocity time graphs. And in this case, a negative slope tells us we have a negative acceleration. And now that means the speed is decreasing. In other words, it's slowing down. Not necessarily direction going backwards like it was on a position versus time graph, but that the speed is decreasing. One final thing we can do with a velocity versus time graph is look at how far the student traveled over certain increments of time, for example, from 4 seconds to 6 seconds. To do this, we're going to look at the area under the curve. In 1 second, he would travel 20 meters because it's traveling 20 meters per second, and in another second, another 20 meters. In other words, 20 by 2 seconds, the area under the curve. Now if we look at from 0 to 4 seconds, this whole segment, now we've also got this part that has a slope to it. So the area under the curve becomes looking at the area of a triangle. 1/2 base times height will tell you the area of the triangle. So again, we've got 20 on this axis, 4 on this axis, and then we take half of that. So in this video, we looked at two types of graphs. We looked at position versus time graphs, the slope of which will tell you the speed or velocity, and velocity versus time graphs, the slope of which will tell you acceleration.